Oops. Hello, my name is Nicole Ale, and I chose to review the article Using Argument as a Tool for Integrating Science and Literacy. I chose this topic because I'm a chemistry teacher and I'm always looking for fun and exciting ways to include literacy in my curriculum. I also, though, do not want to get rid of the inquiry based learning that my students get to experience. So I thought this article would be very interesting and helpful to me. It was written by Aaron Washburn and Andy Cavagnetto. So before we get started on the actual plans to integrate science and literacy into the curriculum, I wanted to define literacy. And you can see up here it says that literacy encompasses the language based acts of reading, writing, listening, speaking, and viewing. So when you break it down like that, it's really not that hard to think of ways to include literacy skills into science. And the authors actually argue that the integration of literacy and science is an essential component to actually learning science. If you don't have literacy, you can't very well become a scientist or even learn many of the scientific concepts. Because scientists must generate questions, they also need to craft research proposals and funding requests. They need to be able to present their ideas in a clear manner, and they need to make, negotiate, and justify their claims. And here I have a picture of two children playing with a string can telephone. And one of the activities that was highlighted in this article was a teacher using a process that we're going to learn about to help kids um, investigate the best way to make string can telephones. So, the 5 step scientific method that we all know and love, which is right here, um, has us ask a question, construct a hypothesis, test with experiments, analyze the results, and formulate a conclusion. Um, this method is a little bit antiquated and it fails to actually capture the literacy rich aspect of science, and it views science as slowly a linear process. So, how can this be fixed? Well, to integrate literacy into the science curriculum, a more interactive approach should be taken. And how do we do this? Well, the authors view argument as an essential part of this. So, when you think of the word argument, many people automatically think of what you're looking at in this picture here, where there's just a few people and they're quarreling with each other. But argument, um, from a scientific viewpoint, is actually providing an assertion or claim about an unresolved issue and having a reason for this assertion. So it's not this traditional quarreling that we see here. So, how are we going to get literacy, argument, and scientific investigation all wrapped up into a lesson that a teacher can feel comfortable presenting and teaching to the class? The authors propose using the PONG method. The PONG method is an acronym for problem, observation, negotiation, and goal. So what is going to happen in the Pong method is you start up here with the problem or the question. The teacher is going to pose a problem or shares a focus question for all of the students. And then the students make their observations. And then they're going to make an evidence based claim, and then they'll share and have their claim critiqued. And this is where the negotiation part comes in. They're going to take those critiques and they're actually going to make adjustments and revise their evidence based claim as a result of that sharing. And hopefully that will get them to their end goal here. This Pong Cycles framework looks a little bit different when you're including everything. And within this Pong cycle, there are 6 mini cycles. The first mini cycle is negotiate the questions to explore, and then we continue on generating investigation designs, making a prediction, a hypothesis, generating claims, and moving toward understanding, checking with the experts, and then finally the last cycle is reflect on how ideas have changed. And so this can seem a little bit overwhelming for the teacher. So if we look at this table, it shows us the different cycles and then different applicable negotiation strategies that could be used for this. So we'll look here. If we are looking at student understandings, this is like a pre-assessment, I would say. You can do a question generation, an AKWL chart, or some quick writes just to assess, okay, what do the kids already know and understand about the topic at hand? And then the next step would be to generate a focus question. You want to pick something here that the kids don't already have the answer to. That's why this first pre assessment step is so crucial, because you don't want to go through these steps without the kids having something to explore. And so when they're generating their focus questions, they're going to think, pair, and share. They could do jigsaw or even a graffiti or carousel brainstorming. This graffiti or carousel brainstorming is if you had like posters all up over the classroom, and maybe each group of students has their own poster and they put their own ideas, their own questions up there, and then you rotate the students, and then they can write on the next person's poster just other ideas that they think of when they see what the first group had come up with, and they go all the way around the room until they get back to their room or their poster, and then they can look at all the other ideas and maybe even formulate a better focus question than they originally had. And then they're going to generate their investigation designs using the same techniques, and then they'll make their predictions and hypothesis. And they can do this with a think, pair, share, or a double entry diary. Then they're going to be generating their claims and moving towards common understanding. And then what do the experts say about the topic? This is the time when you can do reciprocal teaching or a double entry diary. And then here you're going to be providing opportunities to reflect on how ideas have changed. You can do this with creative writing. One example of creative writing is the raft idea. And the raft technique is another acronym, and the R stands for the role of the student. The A stands for the audience. So who are they going to be presenting this to? The F stands for the format. Is this going to be a journal entry, a letter, a speech, a play? And then T represents the topic and the purpose. So what topic are they going to be presenting, and are they going to be trying to just do a persuasive speech or informative essay. How is that going to look? And then finally, they're going to provide opportunities to apply the big ideas through quick rates and peer reviews and things like that. So, as you can see here, this is a really good um, framework to think about integrating literacy while you're investigating a scientific issue. So, what are the benefits to this? The Pong method really helps teachers plan for the unknowns while also still providing inquiry based lessons. It allows for flexibility because each cycle within the Pong method allows you to revisit it, or you could even take little pieces out and come back to them at a later time. It's really up to the teacher and how the students are reacting to the lesson. And then it improves literacy as well as science skills. It's not separating them and making um, it boring just by saying, okay, let's just write about, a scientific topic. It's more inclusive than that. So now you're probably thinking, oh my goodness, I really want to put this in my classroom. And I'm glad for that. So here is a chart that will help you do that. So you can first think about the goals for each cycle. And we have the 6 cycles, so just put one goal for each cycle. And then you're going to write your literacy practices or strategies for the negotiation phase of each cycle. And then you can finally pair it with the Common Core State Standards. And then you can implement your lesson and know that you are integrating literacy into the science classroom. Thank you so much for your time, and I hope you have a great winter break.